Good evening, class. Today we are going to review a quiz that we just had on word problems involving multiplication. So on our first problem here, you'll notice that we have correct answers already solved. This was actually a student's quiz that I took some pictures of because she had done most of her work on a separate sheet. And this way, you can see the number that we're looking for, or the answer that we're looking for each equation. So for the first one, let's go ahead and do what a lot of kids like to do. They like to highlight the important information. And this is a good strategy. So right off the bat, we know that we're going to read it. Shelley has 150 containers in her storage room. Each container has 56 pencils and 24 pens. Which of these will give Shelley N the number of pencils she has in the storage room? Now, what they mean by which of these, they mean which of these number sentences or equations. A number sentence and an equation are the same thing. So let's go with this. We start off with 150 containers. Each container has 56 pencils. Now, I didn't highlight anything else yet, but I am going to highlight very quickly N, the number of pencils. Now, the reason I am putting some emphasis there is because there were some questions on this particular problem about what the question was. And the question is, how many pencils? Let's thin that down a little bit. 24 pens is not important. They're not asking about pens. So we can scratch that out. We're not worried about it. We know that we have 150 containers, and there's 56 pencils in each one. So if there are 150 groups, containers, each group is 56, then that's our answer. 150 times 56. There we go. Now, like I said, several people, a great number of you, thought that we needed to get the number of pens as well. If that was the case, then it would be 150 times 56 plus 150 times 24 equals N. But none of these really work out that way. If you did the total sum, you could do this, 56 plus 24 times 150, but that doesn't solve the question either. So basically, none of these are going to work. And you could easily just mark those out as you went through logically. So let's move to number 2. A company bought 22 computers that cost $3.99 each. What was the cost of these computers? You have a couple of different options here on how you want to do this. One thing you could do is you could estimate to get an idea of how much you're looking at. So let's say we're going to, again, let's start with the number sentence. The number sentence is bought 22 computers at $3.99 $3.99 equals total cost. I want to get an estimate before I do my calculations. So I'm going to round $3.99 to 400. And I'm going to multiply that by 20. Alright? So 2 times 4 is 8. 1, 2, 3 zeros. That's our place values. So we know that it's going to be around 8,000. Now that estimate is great, but it doesn't really solve us right away because so many are so close. 7,678 is close to 8,000. It's about around 400 less. 7568 is really close to that, so it's viable. We know that we actually estimated low. This one's right out. Just not going to happen. This is probably our solution. Because if we had added another 800 here, we'd know that our estimate came to 8,800. So that's probably going to be our answer here, the 8778. But let's go ahead and do it correctly. So we do, and let's do this with the box method, the array. We're going to expand out 399. So 300 plus 90 plus 9. And then we're going to expand out 20 into 20 and 2. And we draw our array. A little plus sign there. Now you could do this with a standard algorithm, and there's absolutely nothing wrong with that. I'm doing it this way just to show a different method. So 2 times 3 is 6, because when we do the array, what we are working with is primarily the non-zero integers. So 2 times 3 is 6, and we add up the zeros, 1, 2, 3. 2 times 9 is 18, 2 zeros. 2 times 9, 18. Now for the second digit down here, 2 times 3 is 6, and 2 zeros. 2 times 9 is 18, and 1 zero. And 2 times 9 is 18. So now we just add these things up. So this line becomes 6,000, 1,800, 18. Add that up. 8, 1, 8, 7. 7,118. Now we do this one. So 600, let's box that for a second. 600 plus 180 plus 18. 8, 9, 7. So these two get added together. And I'll do that in red just to make things, we'll do it in blue. So 7818 plus 798. And what do you know? I made a mistake. So I did 2 times 9 is 18. But that's not right. Because 2 times 9 is 18, but we have a 0. So that should actually be 180. Now, what we got to do here is we could try to just fix this. But is it really going to work out? Probably not. So let's go ahead and erase our error. And let's put back in that 180. So 0, 8, 9, 7980, not 7818. So again, let's erase this. 7980 plus 798. Now, since we made a mistake, let's go ahead and make sure that we did that right. 2 times 3 is 600. Cool. 2 times 90 is 180. 2 times 9 is 18. That's correct. So now we can finish off this addition. So that's 8. 9 plus 8 is 17. 9 plus 1 that we just carried is 10. 7. Carry over that 1 again, and that becomes an 8. 8,778. And that is our solution. Great. So let's go ahead and move on to number 3. Number 3. A company makes 625 cell phone cases each day. How many cell phone cases does the company make in 31 days? So again, let's go ahead and this time we're going to use a slightly different method. Just for practice. We're going to make ourselves a window pane. And then we are going to hashtag the important information. So company makes 620, whoops, that's a highlight. 600, still did it. $620 phone cell cases each day. And 31 days. So, hashtag 625 cases. Hashtag 31 days. Let's make that 625 cases per day. And then 31 days. Hashtag how many cases in 31 days. So this is our, I'm going to label these main idea. The question, and then over here we're going to write our number sentence, actually our equation. So 625 cases times 31 days equals T for total. And now we solve it. Solution. All right. So, again, we can do this any number of ways. We could even do the estimation like we did before. Now, this is really easy because we don't have to round it to something inconvenient. The whole point of rounding is working with what we have. 625 is a nice, easy, calculated number. And multiplying it by 30 makes it really easy. In fact, it's so easy we don't even have to worry about doing any extra steps here, because we can put that 0 down, because we know that the first section is going to be all times 0, right? So that's our placeholder. Our ones place is a 0. 3 times 5 is 15. 3 times 2 is 6. 1. 6 plus 1 is 7. 3 times 6 is 18. So 18,750. And since we did 30, we can just add another 625. So that's 5, 7. 6 plus 6 is 12, plus another one because it's 7 is 13. That comes to 9. Carry down the 1. 19,375. So we know our solution is 19,375 cell phone cases per day. And we box our solution, and we're done. All right, now on number 4, Gus collects sports cards. He has 108 packages of cards. Each package contains 15 cards. How many sports cards does Gus have altogether? All right, 108 packages. Each package has 15 cards. Let's do this as a standard algorithm. (108), 15, multiplication sign, draw our bar. 5 times 8 is 40. 5 times 0 is 0, but we have to add that 4. 5 times 1 is 5. Because we're now moving to the tens column, we place a placeholder here, because we're really multiplying by 10. And then, because it's 1, we can just go 108 and make sure that our columns are nice and neat. Bring that down. 0, 0, 4 and 8 is 12. Carry that 1. 5 and 1 is 6. And then bring down the last one. 1,620 cards all together. Easy. Now, the most common error on this particular question was an arithmetic issue. The place value was not set. This has been the most common error on most of these types of problems. If place value is going to be an issue, you have a couple of different ways that you can do it. First of all, using the array does allow you to visualize what kind of places you're working with here. So 108 would expand out into 100, and you can put the tens here, hundreds place, tens place, ones place, and then 10 and 5. And then you just multiply it through. So once you multiply that through, as we showed in a previous problem, you just add these all up. So that's 1,080. And that's 540. Zero, 8 plus 4 is 12. 6, 1,620. Same answer. We double checked ourselves. Everything looks great. Number 5. Pam wraps holiday gifts at a department store. Each bolt of wrapping paper can wrap 155 gifts. If the store has 12 bolts of wrapping paper, How many gifts can Pam wrap? Alright, we got a little bit going on here. So, just for the sake of organizing our thoughts, we do the window pane again. So, the question, let's start there. How many can she wrap? Each bolt of wrapping paper can wrap 155 gifts. She has 12 bolts. So, 12 bolts times 155 gifts. Because you can think of 155 gifts as how many each of these groups have. There are 12 groups of 155. And as we know, that would mean 12 times 155. Because what we're looking at is 12 groups of 155 equals total gifts wrapped. So, now we are going to do this in a standard manner. Actually, let's do this a little bit differently, just like we did before. We're going to do 155 times 10 to make our addition simpler, and because of the space we have here. So, 0 for the first place, and then 155. So 10 of them gives you 1,550. And then, just to do repeated addition, 10, 10, 1, 11, so 310 is our next group of 2. So this is 10 of them. That's 2 of them. So 1,550 plus 310, 0, 6, 8, 1. 1,860. Booyah. Done. Let's move on to number 6. One of the largest hotels downtown has 23 floors and accommodates 150 people on each floor. If the hotel is completely full for 3 nights this week, how many people will the hotel accommodate during these 3 days? I saw several interesting versions of how this question was solved. But the biggest error that I saw was that they didn't really understand that it was for 3 nights. So what happened is people would get those 23 floors and 150 people and call it a day. But that's not actually the question. The question is, if they're completely full for 3 nights, how many people will they do during those 3 days? So, 23 floors times 150 people times 3 days equals total for 3 days. There's a couple of ways you can do this. Because we are going to work this in the manner that we do some other problems, we are going to turn this into kind of an order of operations brief, even though you could do this to 2 separate equations. So, for instance, 23 times 150 times 3. Let me draw our little narrowing lines. So 23 times 150, we'll do it right to the side. I like to put my larger number on top just for the sake of organization, because it doesn't matter what order you multiply them in. So 3 times 0 is 0, 3 times 5 is 15, 3 times 1 is 3, plus 1 is 4. Placeholder, 2 times 0, 2 times 5 is 10, 2 times 1 is 2, plus 1 is 3. So the first one is 3450. And that's 3450 times 3. So do that again. 3450. Maybe we don't want to do multiplication. Maybe we just want to add it up. You can do that. It might save you time. Just depends on how comfortable you feel about your multiplication. So we can add those all together. 0, 3 5s is 15. 3 4s is 12, 13, plus the 1. So carry that up. 3 3s is 9, plus 1 is 0. So it's 10. Now, am I right? Maybe I'm not. I mean, what I got is an answer. But is it correct? So we could estimate, we could guess, we could check. And one of those ways that we can do this, without going through the entire equation again, is look at what occurred. We know that 150 times 20 is over 3,000. So we can bet that that's correct. So 150 people, 23 floors, is 3,450 people. And then multiply it by 3. So we can discount that answer. 519 is not right. 3450 is not right. 450 people is not right. That means that our correct answer is actually 10,350 people. Dominique collects number 7. Dominique collects stickers. She has 903 sheets of stickers. Each sheet has 12 stickers. 400 of those stickers are animals, and the rest are cartoon characters. How many stickers does Dominique have? Mark your answer. There's a lot of information here, but is all of it important? How many stickers? Not animal stickers, not cartoon characters, just stickers. So we don't need to worry about that 400. Get rid of it. None of this matters right here. Just cross it out. We already got our question. So we know that she has 903 sheets and 12 stickers per sheet. Nine, 3, 12. 2 times 3 is 6, times 0, times 9 is 18. Place value, and then 1 times 903. 903. We're running out of room here, so do it over here. 1806. 9030 6 3 8 10 10,836. She has 10,836 stickers on 903 sheets. All right. Number 8. Plainview Middle School is having a fundraiser for a winter ball. Each student needs to raise $25. If 263 students in the middle school raise $25, how much money will there be for the winter ball? All right. Information that's important. Each student needs to raise $25. 263 students. How much money? So, I'm not going to use the window pane this time. I'm going to do this a little differently. If 263 students raise $25 each, how much total? Because that's the essential question. So at that point, it just becomes multiplication of those two numbers. Let's do them as expanded. 200 plus 60 plus 3, and 20 plus 5. Four and 3 zeros. 1, 2, 3. 12 and 2 zeros. 2 times 3 is 6. And I remember that I made an error earlier on this very same kind of problem. So I put a 0. I made sure that 20 times 3 is 60. Boom. 5 times 2 is 10, and then we add the other two zeros. And then 5 times 6 is 30, and we add that last zero. 5 times 3 is 15. And we can add all that up. Now we can do this in our head if we want to. 4,000 plus 1,200 is 5,200 plus 60. 5,260. And this is 1,315. 1,315. Because we know, just like we were able to expand those out, sometimes if the numbers are convenient like this, we can just put them back together as easily. One of the advantages of expanded notation is that it does break the numbers into more readily calculable chunks. So we just add that up. 5, 7, 5, 6. 6,575. There's our answer. And then we put a dollar sign on it and total. Just so that we know what we answered is logical. So when we ask ourselves again, if 263 students raise $25 each, they will earn $6,575 total. Easy enough. All right, in the home stretch, number 9. Frida has saved $150 for each of her 13 grandchildren, and $75 saved for each of her 5 grandchildren. What should Frida do to find the amount of money she has saved? So what we have here is two equations, because what we have is 150 for 13 grandchildren, that's one question, and 75 for 5 grandchildren, 5 great-grandchildren, and those two are going to add up. Since we're doing addition, and we're not being asked to solve, we're just being asked to find what she needs to do. So if we're doing addition, but are we? See, we're not adding two things. We're not adding 150 plus 13 and 75 and 5. That's not right, because that wouldn't be enough. It's 150 for each of her 13 grandchildren. So that's totally wrong. And this was something that several people did. We summed 150 and 13 and added it to a sum of 75 and 5. It is more like what we need to do is find two products and add it together, because we're multiplying. So this is a product plus a product equals total saved. So let's look for those key words. Find the sum of 150? No. Find the difference? Well, we're not subtracting anything. We're not dividing anything. Find the sum, again, not a correct answer. But here we have a product of 150 and 13, and that's one of our questions. 150 and 13. And then add it to the product of 75 and 5. 75 and 5. So there we go. Number 9 is B. Frida would find the product of 150 and 13, and then she would add it to the product of 75 and 5. Here is our final answer. Well, final question. Paula owns a candle shop. There are 273 shelves in her shop. She has 25 candles on each shelf. She also has 50 candles in a display case. How many candles does she have on shelves in her shop? So we don't have to, for this particular question, go and find the key question, because they actually just say it right here. How many candles does she have on shelves in her shop? Cool. So the only thing we need to worry about then is that there are 273 shelves and there are 25 candles in each shelf. So these numbers are close. Maybe estimation is not the best idea. But let's do it anyway. Let's say we want to go ahead and, just because it's an easier number to work with, instead of 273, we do 270 times 25, and we do 25 and 3. That's because it kind of makes it a little easier to calculate. So 5 is 0, 5 times 0, 5 times 7 is 35, 5 times 2 is 10, plus 3 is 13, put that placeholder, and then 2 times 0 is 10, carry that 1, scratch that out so it doesn't get us confused. 2 times 7 is 14, plus 1 is 15, 2 times 4 is 10, I'm sorry, whoops, not 2 times 4, 2 times 2 is 4, plus 1 is 5. So that, nope, right out of room. 0, 5, 8, 6. Well, just by doing the first section, we know that these two are wrong. Just by doing 270 times 25, we know that those two answers are wrong. But we'll go ahead and finish adding it up. So 25 times 3 is easy, because it's 3/4 basically. So it's 75. So we take that 6850, add 75 to it, 5. 5 plus 7 is 12. 8 plus 1 is 9. And then 6925. Did I make an error? Maybe I didn't. And we know that F's going to be the answer. But when I did the math, I wasn't quite right. So maybe we should double check ourselves. What did we do wrong? Because it's important to do these things. Maybe what we need to do is we need to start from scratch and do it the clean way. So let's go ahead and do that. We're going to erase this over here. Just start all over. Don't let ourselves get distracted. Remove all of this. This is the great thing about using a pencil. So, because we made a math error, let's do it a different way. Let's not do the standard algorithm. Let's break that up into 270 and 3. And break that up into 20 and 5. Two times 2, 4, 3 zeros. 2 times 7 is 14, 2 zeros. 2 times 3 is 6, 1 0. 5 times 2 is 10, and 2 zeros. 5 times 7 is 35, 1 0. 5 times 3 is 15. So 4,000 plus 1,400 is 5,400 plus 60. So that's 5,460. And that one's going to be 1,365. 1,365. Cool. So we add those up. 5 plus 0 is 5. 6 and 6 is 12. Oh, that's looking better because that matches our answer. Bring that up there. 1. 4, 5, 6, 7, 8. Cool. And then 5 and 1 is 6. 6825. And now, because we used a method that allowed us to eliminate these two answers, but we made a math error, we can verify just to make ourselves comfortable that that is, in fact, the correct answer. Over the course of this review, I used several different methods. We looked for key questions, we looked for keywords, we did window panes, we did standard algorithm, we did an array, we did repeated addition. There are other methods that you can use. Making placeholder charts is sometimes important. Sometimes it is important to do your multiplication tables. Just work out the multiples. It can save you time on future problems if you have similar products that you're working with. The most important thing when you're using these strategies is that when you are doing a word problem, your goal is to identify for yourself what the question is asking. Then find the important information that is relevant to that. Determine what the next step is. And from there, you can solve. So the last thing I'm going to do here, just very quickly, that looks terrible. Word problem strategy. Window pane. These don't have to be done left to right. They can be done in the order in which you find the information, as long as you make sure that you do your best to ensure that what you're doing is actually what you need. So, in this case, the main idea is number facts relevant to the question. Look for distracting info. Your question is what the problem needs you to solve using number facts. The equation is a number sentence that combines number facts to get the solution to the question. And the solution is the answer. Success. One important thing, label your answer and make sure it solves the question. That's all, folks. Thank you very much.